without understanding tornadoes, it turns out you can't really understand storms, because tornadoes or vortices in the atmosphere are the entity that actually delivers the energy of storms. Right now, there's a gigantic misconception that the energy of storms comes from the local environment. It comes from this notion of convection, or this notion that air wants to rise, which is actually a nonsense notion. So the question is, what is solving tornadoes? Well, solving tornadoes is trying to solve what it is when you see a tornado, and specifically I'm talking about when you see that very distinct structural or tubular structure, I should say, of a tornado, and you ask yourself, well, what is that? How is it possible for that to be doing that? Now, if you ask a meteorologist or you ask anybody in academia now, they're going to have a phrase for it. They might refer to it as a condensation tube. Here's the thing though, condensation doesn't do that. Condensation doesn't form tubes. It doesn't, and we all know that within that tube there's fast-moving air, and that fast-moving air is kept separate from the air on the outside of the tube. Now, condensation doesn't do that. I don't care what anyone says. Anyone wants to pretend like they understand something, they should at least try to make sense. And what we see with meteorology is they don't bother making sense because they kind of have the bully pulpit. You know, they can say whatever they want. But the purpose of solving tornadoes is to solve that. What is that? What is that tube? And so that's what solving tornadoes is. And it turns out the correct solution to that, which will come further along, I'll have to convince you of that, is that it is actually a characteristic of water. A relatively simple way to think about it is that we all know that water has this quality called surface tension. And we know that the word tension means that there's forces between the molecules. And if you get these consistently, you can form some kind of a structure, as we see on the surface of water, and that's what we see. We see a layer of water that is actually hard. It's very thin, and therefore you can't really notice it. But if you imagine if there's some way to increase the surface area of water, then you can also increase the surface tension. And that's really what's going on with the tornado, is that it's the water therein that has, under certain conditions, achieved a higher degree of separateness from itself. And that separateness introduces more tensional forces, and these tensional forces, as long as it's not if it's not very far from each other, the water molecules can then form a kind of a plasma. And that plasma is what actually makes up the tornado. Now, to understand that, we have to understand water. And so that's what solving tornadoes is about, is understanding water. It's a necessity, because without that, you can't really understand tornadoes. And by the way, without understanding tornadoes, it turns out you can't really understand storms, because tornadoes or vortices in the atmosphere are the entity that actually delivers the energy of storms. Right now, there's a gigantic misconception that the energy of storms comes from the local environment. It comes from this notion of convection, or this notion that air wants to rise, which is actually a nonsense notion. Really, the source of the energy of storms is delivered through tubes, and it sometimes comes from hundreds or even 1,000 miles away. And the repository in our atmosphere for this energy is the jet stream. That's literally what the jet stream does. And it is these tubes made of a plasma of water that deliver the energy of storms. So you can't understand tornadoes until you understand water, and you can't understand storms until you understand how this water can be made into a plasma. And it also turns out, though, you can't really even understand the distribution of airflow on our planet, which is heavily dictated by the fact that storms or storm activity is what directs it. Now, previously this was referred to as convection, and so they have this notion that the Hadley cells of our greater atmosphere, our atmosphere splits itself up into these certain cells within the troposphere. And these cells have a certain circulation pattern, and this circulation pattern has long been assumed to be pushed along by convection. Well, it turns out convection is a nonsense word. It doesn't really happen. It doesn't really happen in our atmosphere. It's just one of those filler words because everybody was confused. What's really pushing the atmosphere, or I should say actually pulling, because that's really what's happening, is this plasma forms up in such a way that it creates a suction, and the suction is what causes storms, and the end result of that collectively is what refers to as the circulation of our atmosphere, and that greatly influences and causes the relative equalization of pressures and of heat around our atmosphere, which not only distributes water for us, you know, storms are the water distribution system of our planet, but it also makes our planet much more livable. And so that's what solving tornadoes is about, is solving all that. It's putting that all together in a piece and get us beyond the superstition, which currently completely dominates all of meteorology and even all of climatology when it comes to the question of what's causing this greater circulation.